Okay, so today we're going to talk about the second part of 9.3, multiplying and dividing rational expressions. Now the nice thing about this is there's not a whole lot different than just simplifying. The only thing different is you got another fraction here. But other than that, all the other rules still come into play. In other words, you can't cancel out terms, you can only cancel factors. Now one of the things I'm going to do or ask you not to do to make your life a little easier is we're not going to find restrictions on these. So basically, you're going to look at this problem, like for instance number 1 right here. You're going to do the best you can to factor it and then see what you can simplify. So let's just get started here with number 1. Up on top, if we just kind of go top to bottom here, I take a look at this and I notice that I can factor that. X minus 8, x plus 3. Now down here on the bottom, looks like I could factor out a monomial of 2x. When I do that, I get 3 plus, looks like x times, let's see, nothing with 5x squared, so I'll just leave that. And you can't really do anything with x minus 8, so I'll leave that. So my suggestion is factor everything first, and then take a look at what you have. Now remember, with fractions, just like when you were multiplying fractions back in whatever grade that was, 2nd, 3rd, 4th grade, you can reduce up and down, or you can reduce diagonally. So as I take a look at this, I see I have an x minus 8 right here that I can reduce with this one. I have an x plus 3 and a 3 plus x, which are the same thing, so I can reduce those. And then I notice I have an x here and an x squared. So that means I can reduce one of these x's with 1 up there. And so what do I have left? I have a 5 and an x left up on top, and just a 2 on the bottom. And I'm done. That's it. Now believe it or not, one of the things that probably trips people up the most is just simply sloppiness. You do all this, they start crossing things out left and right, and next thing you know, they've forgot an x or they forgot something else, so make sure you're being really neat. Okay, let's move on down to number 2. Once again, like I said about the last notes, this is a good set of notes here where before I actually do it, it would be helpful if you actually hit pause and tried it on your own. So that's what I would suggest to you, is to hit pause right now and see if you can reduce this one. Alright, so here's what I would have done. Now the left fraction is easy. There's nothing you can do. Now the right, looks like this is a difference of 2 squares, so I could factor that. W plus n, W minus n. Now down here you can't do anything either. So looking at this right now, hopefully you notice you can cancel these. Now hopefully it feels like you should be able to reduce these. Now they're not exactly the same. If you notice that the a and the y are switched around. Well, you can reduce those. Those are opposites of one another. It's kind of like having a 3 and a negative 3 where they'll reduce. And just to kind of demonstrate that, if I take the top one, what if I factored out a negative 1 on top? Well, the a would become negative a, and the y, this minus y, would become plus y. And what we have left over here is w minus n and y minus a. And now if you notice, y minus a and negative a plus y are the same. So they actually do reduce. And what am I left with? I'm left with negative 1 w minus n. Or probably a little more simplified would be distribute that in there. You'd get n minus w. Okay, there you go. Now that little trick right there, you don't have to show factoring out the negative 1 if you don't want to, but you should notice that when you have binomials like this where the variables are switched and it's minus like this, these are reducible. They just reduce to negative 1. They're just opposites of one another. Okay, so let's move on down here to the third example. Again, I would suggest hitting pause, give it a shot on your own, and then I'll go through it. Now remember, division. No rules aren't any different with division with rational expressions than they were when you were doing fractions way back when. You still need to change this to multiplication and take the reciprocal. So I'm going to do 2 steps in one. I'm going to actually factor first. So factor. And this is a difference of 2 squares. Now I'm going to multiply. And if I were to factor this, now I'm flipping it, so I'm going to put it up on top also. I'm going to factor this and flipping it, so it'll go on the bottom. Let's see, that'd be x plus 2. I think I did everything right there. Now we're just down to what can I cancel. Now remember, with anything that involves these fractions, multiplying and dividing, you cannot do any reducing or canceling until you change this to multiplication and flip it. Then you can start canceling. Okay, don't start canceling right here before you've done any of that. So it looks like I can get rid of these, the x plus 3's, get rid of the x plus 2's. I also notice here 3 goes into 3 once and into 6 twice. But then I also notice that that's 2 and 4 can reduce. So 2 goes into 2 once and in this twice. So a lot of stuff going on there. So what do I have on top? I just have a 2. And the bottom looks like I just have an x minus 3, this 1 and this x. So I'm just going to write it like this. Now to make your life easier, technically if you want to be truly simplified, you should distribute this back in, which is fine. But I will allow you to leave it just like this if you want. But just to understand, to be truly simplified, you should actually distribute it back in. Okay, last one. So this one's kind of ugly looking. You notice there's a fraction within a fraction right there, or 2 fractions within a fraction. Well, remind yourself, what does the fraction bar mean? Well, it means division. So while this one looks kind of ugly, I can actually rewrite it and make it nicer looking. So if I rewrite the first one, and then now instead of that fraction bar, I'm just going to put divide. Well, that makes it look a lot nicer. Makes it look a lot like that third example we just got done doing. So that's my suggestion. When you get problems like that, that's pretty common, you know, SAT, PSAT, CST type question, making it look real complicated like that. But in reality, it looks just like this. So we'll go right back to what we did on example number 3. I'm just going to factor. On the top one, hopefully you recognize that's a sum of 2 cubes. So that would be x plus 2, x squared minus 2x plus 4. The bottom looks like I can factor out an x. Over here, multiply and flip. So if I factor this, x plus 2, x plus 2, and bring that down. Now I'm not going to multiply all that out, x plus 2 cubed. I'm just going to remember that it just means this. And so I can do a lot of reducing here. Looks like we can get rid of a ton of stuff. Looks like rid of this, with this, this, with this. I can even get rid of this and this over here. This does not factor anymore. It doesn't look like it can reduce anymore, so I'm just going to rewrite it as x squared minus 2x plus 4 over x times x minus 2. And like I said in the previous example, to be truly simplified, you should distribute that back in, but I'm not overly concerned about that. If you can just leave it like that, that would be fine as well. So that's it. That's simplifying rational expressions when you have multiplication and division. Hopefully that made sense. As always, if you had a hard time with something or you got stuck on something, just make a note of it, and then when we see each other in class, just ask. All right? Thank you.